Week 3, Lecture 1, OOP. Object-Oriented Programming, or OOP, is integral to the full potential of C# and .NET. As the name implies, OOP makes use of objects, which can be a block of code, a process, function, or something else entirely. Using objects allows streamlining and reuse of code. Objects can be referenced and activated as needed and where needed. A class refers to an object type. When a class is used, it is given a name, which creates an instance. The book uses the analogy of a blueprint to illustrate a class. The object is the actual thing built using that blueprint. As we work with classes and objects, we'll look briefly at Unified Modeling Language, or UML. UML is an excellent way to visualize instances and classes. You can break down fields and properties, which allow access to classes. Accessibility options can also be added to represent public, a plus sign, and private, a minus sign. Properties do not directly access the data, whereas fields can, but properties provide more control of behaviors. Accessibility can be a concern, so properties can be used to limit access to fields and the data they contain. As we learned in the earlier discussion of functions, the word methods is not always interchangeable with functions. However, methods refer to functions exposed by objects. They can be called and return values just as functions do. In the broader sense, everything is an object. Classes, functions, everything. C# and .NET rely on objects. An object is constructed, used, and destructed, called a lifecycle. Constructors instantiate the objects and use the new keyword. Shiny object, my object, equal new shiny object. Once the object has performed its task, destructors clean up. Unless given instructions to do otherwise, the object will be destroyed during the garbage collection process. Events act on parts of code to make something happen, and event handlers are used to make sure the triggered event occurs smoothly. Event handlers are used in a variety of languages. While the syntax may differ, the concept is the same. C# stores data in variables in two different ways: as a value type, with data stored in memory within the variable, and as a reference type, which contains a reference to another location in memory, the heap. Value types will always have a value, whereas reference types can be null, having no value. Nullable types are a way of making value types behave like reference types. Both string and object are reference types.